Hello and welcome back. So in this video, I will show you a comparison of a snappyHexMesh against another tool. So I mentioned that we're going to use snappyHexMesh, but then compare with something else. And I'm going to use Ansys workbench, workflow to do the mesh. So the first is that the geometry always created in onshape. One thing that here, right click, and then I export it, not in STL format, but now a step format. Okay, that is a proper cat exchange format, works very well. And here, let me launch my tool. So I will use first, the workflow here will be geometry in the spaceClaim, and then I move to Fluent to do the meshing. So let's work first. Let me launch a spaceClaim. So in theory, I can create this geometry also in a spaceClaim. However, spaceClaim is not a fully parametric CAD. I really like to use parametric tools, so that's why I did it here. But there is no problem doing the geometry here in space. So let me show you how things work. Okay, here. So bam, 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 bam. Let me go mixing elbow open. I already have it there prepared, but let me go here, and this is the step file, and it's very clean, very transparent. You will see everything, and here you have your solid. Okay, now that you have this here, you can modify this geometry and space. I don't want to go in details. There are many other videos, and probably I will prepare some other videos. But what we need to do here, now that we have our fully parametric CAD, is to create the face group. Okay, for boundary conditions. Always the issue with the geometry is that. Okay, so now using spaceClaim or any CAD tool that can that you can modify a step file is much easier than using a step files or OBJ files. So to do that here, you need to create groups. So I will start to select faces. So see that you have the structure here. You go into groups. By the way, I'm using Ansys. The student version is for free. You can download it and use it. So I will call it inlet one. I will use the same naming convention. Let me select here also inlet two. Then I have my outlet here, outlet. So you get the point that you create all those patches, put it here. Let me call this one, like in the case I call it pipe large. This was pipe small, and that's it. You can also add some other geometries, refinement regions, and so on. Okay, in this case, we don't need it. You can also select edges, like the extract edges, and select vertices. So let me select this edge. Okay, so see that you selected there, create. I will call it edge one. If you want to select something else, another edge, you can select this. You have vertices and so on. Okay, so it's very flexible. Now that you have this, you can save it. So let me call it here test one. Okay, and that's it. You have your geometry. Okay, you can also do some checks here to prepare it. I don't go into details. This is very clean geometry. And at this point, let me close. So we have all the groups. So they say creating the face group always is fundamental. It's very important. And now let me go here. I will work in this directory here. So the student version, the maximum number of processors that you can use is 4. Then be careful running meshing. We want to do the mesh, and then it's 1. You can do the solution. I'm not going to do that. Okay, then you have a mesh, you can export it, and then that mesh you can use it in OpenFOAM converted. So at this point, let me click start. We're ready to go. We're going to launch the meshing tool, which is fantastic. So Ansys have 3 meshing tools. Fluid meshing have ASCII CFD, which is fantastic also. And then you have Ansys Mechanical, Ansys Meshing, which is also good. All of them are good. As you see here, we have a graphical user interface. It will make your life super easier. And as I say, I don't use very often Snap. Probably I have been talking a lot, showing many techniques and so on, but I spent a lot of time and I realized that if you can use something else, better use that other tool. So that is my advice. If it's the requirement to use a Snappy, okay, you need to use it. But if you can use something else, use something else. So most of the time that when I work doing consultancy, whatever, people say, okay, it's not a requirement, snappyHexMesh. I go for another tool. So here we're using Ansys. There is a Enova that we have also plenty of videos with Enova and many more. So here to work, let's use the simplified workflow. So look at that. You have watertight geometry when you have a clean geometry. We have the cat geometry. We have perfect control. And look at here, they call it fault tolerant. This is a dirty geometry. This is what you use when you have STL files, okay? So if you want to work with STL files, you choose this one. It's a little bit more complicated, but it's much, much easier than the Snappy, and things will always work here. But let's use the watertight. So you have a workflow, vertical workflow from top to bottom, and well, self-explanatory, these steps. So let's go the first one. Let me import the geometry. Let me go in meters, and let's select the geometry. So here, what it's going to do, Fluent, is going to read the geometry. Then it's from this geometry, this one, it's going to extract the name, the cat plus the face groups, no, the name selections or patches, whatever you want to call. Okay, so let's wait while it's doing this one. So as you can see, also you have many options, no? So cat and any meshing tool, lens and whatever that you use, you have many options that they are not user exposed to the user. You have it there, but you need to expand that. It's not like in the Snappy that you have those dictionaries and you can get lost. Here, they are not exposed, or most of the time you need to do anything. So here, I will take the straightforward approach. So this one at local sizing, it does what it says. So you select yes, and look at that, you have many options. So you can add face, edge sizings, body influence, and so on. So in this case, let me add edge sizing because I want to add edge sizing in this edge that we extracted. So look at that, is you have always these graphical visual references, and you can give an edge size and you get an idea what is happening. So let me put there 0.01, okay? And that's it, the only one. If you want to add another one, just select here, and that's all. So in the next video, probably it's another geometry, we're going to use body of influence and so on. So I'm happy with that. Then we go to surface mesh. So look at that, in surface mesh, you have different methods. So I use curvature and proximity, and we talk about curvature now. So look at in this one, it's full instructor, okay? What we're the technique that we're using, and it gives you this curvature. So usually 18 degrees means one element every 18 degrees. I like to use 12, but here, as it is instructor, as I was talking in comparison to Snappy, that is Snappy, you have the 2-to-1 refinement ratio, so it's very difficult to control this. Here it's very easy, so you can go with 18 with no problem, and even 20 will work fine, but it's up to you, okay? And what I was saying, that advanced auctions, you have many auctions. So you will see some similarities between these auctions and many keywords that you will have in a snappyHexMesh. Okay, it's not exactly the same, but some of them have convey the same meaning. So here, let me recall, I think it was 0.2. Let me put here 0.1. I'll try to reproduce the same value. So it's 0.2, and I'll probably was 0.1. Let me put 0.1 better. Okay, so actually I have it here. So my blockMesh was 0.2, and then I had a refinement level of 2.2, 0.5, 0. Okay, so have an idea here. So let's use this value, and look at how easy it is. I press generate, it will generate a surface mesh, so it will capture everything. So here you do your iterations. Now remember, it's always an iterative process until you find the right parameters. Super fast, always you have these visual references, and very clean, very nice geometry. Okay, no complaints, you refine there very well. Okay, quite nice. Maybe here we can have something finer. So what I say here, we can reduce this one to 12. and it might give you better results. So let me click update, and it will save. We'll do the geometry, and there you go. See that much better. Okay, now I prefer this refinement there. And as I say, you can add more local sizing. So every now and then you can save the mesh, so it will save all the steps and so on. Now the next one here, I have a mesh, I have no voids. Okay, the rest describe geometry. Then here, every single of those name selections, surfaces, the edge doesn't count here. You apply a boundary condition, so there, update, you're okay, good to go. The whole volume, so here we have, these are the cell zones. So remember cell zones, and here you can have many more. We have just one, you can activate, deactivate, and so on, and you are okay to go. By the way, if you want to modify a previous step, you go here, update, and you can modify it. So now boundary layer, and this is the part that is snappy. So in snappy, we have seen that up to this snapping, it works fine. Here, the boundary layer is where you get problems, and I can guarantee you here, you will always get a perfect boundary layer. Unless it is a crazy, super complicated geometry, but you don't have to deal to do all these steps and all those techniques that I show you, in Snappy. So basically, let's do something very basic. Let me put, I think we were doing 10 layers. And let's just look at that. You have different methods here to do, like in Snappy. So aspect ratio, last ratio, uniform. Let me use this one for the first iteration. You can grow only walls, so all the walls, or you can select a specific name selections and advanced. And look at that, you have many advanced options there. Okay, usually they are not exposed to the user. Okay, and layers. If I would recall, this is a pre-build, means that if you do the surface mesh, it will grow the boundary layer and then it will do the volume mesh. Instead, Snappy is post. It will do the volume, the surface, and everything. After you have everything, it will add the boundary layer. So usually pre-build is better, but it's nothing written about that. I like this technique. I'm not quite sure. I don't recall. I need to check, but I'm quite sure that it's pre-built. But in any case, it doesn't matter. And then it comes here, volume generation. So see here the similarity with the steps in the snap, that you do the snapping, then surface and so on. You have all the surface, edge refinements, region refinements, character edges, and so on. You have this exactly the same stuff, and any meshing tool is going to have something similar. And here we have the different techniques, and see that we have different methods: fully polyhedra, poly Xcore, which is the closest to snappy, and fully tetra. I have to say, I already mentioned that for me the best element is polyhedra, and this is my religion. And actually, I think I need to create the charge of polyhedra elements. So if you're walking and you see that charge, likely I will be there. But that is my religion. But there is nothing written that one element is better than the other. Okay, so you follow good standard practices, you will get always a good solution. So Xcore close to what we have in Snappy. And look at that, the options, buffer layers that you have there, number of buffer layers, PL layers. These options are very similar to what you have in Snappy. And even funnier here, you control the quality metrics and so on. So it still is controlling, like in Snappy, it's always controlling what you are doing, the volume mesh, it's controlling some quality metrics. But the interesting one is this one, not the oct3 data structure, not that you have in Snap. You also have it here, and it's the same stuff. You can avoid it. I will leave it here, and then I will show you what happens when I avoid this 128 oct3 transition, which is lethal. It's terrible. I don't like it, but it works. Okay, but I don't like it. I try to avoid that as much as possible. And now let me go generate volume mesh. And off you go. So let's wait a little bit and let's get our mesh here. So it should be quite fast. Also, it works in parallel and so on. And there you go. This is our mesh. And now you can see that very similar to what we were having in a Snappy. Okay, so you have this transition that is terrible, as I was telling. So when you pass from here to here, you are adding a lot of numerical dissipation. And it's very similar to what Snap is doing. It would add some transition from elements. So here it's controlled better, but it still is not ideal. But if you look at the boundary layer, there is no problem here. So in a Snappy, you will having problems now in the somewhere in the geometry, no, here, but here is perfect. As I say, you get something perfect always at the first time. So by the way, to visualize this, is you don't know how to use this, probably I would prepare more videos using this tool because it's fantastic. Okay, so you have here insert clipping. Okay, then you can choose the plane, whatever, you can move it, you can draw these layers, then also displays. You don't see the edges, you can enable there. You can also add transparency, you have it there. So you have many options. Also, you can interrogate, you can measure stuff. Okay, so what you cannot do in Snappy that we were doing in PowerView, you have it everything integrated here, all that information, quality metrics, you have it here. So very nice mesh, perfect mesh. So let's redo it. And just to show you, revert and edit. And instead of using this option now, let me put yes. And here, basically, the transition, instead of having the 2-to-1 transition or that of 3-1-8, now it's going to add elements there to control that transition better. So they can be poly, they can be tetra, okay? And this is what you have. So see that all around where you have transition is adding those elements, and it's a better now mesh. So in this case, it was adding with tetra. We can also control it with poly, but this is better. I like better, but at this point you can do here instead of Xcore, you can add a tetra. And this is it. Okay, so at this point, let me go back here and to show you boundary layer, that here will be always perfect. Let me use another method, and I like to use last ratio. So this will be kind of similar to what we were doing in Snappy. So first height, look at that. We can go here really, really low. So let me go 10 to the minus 4 right ahead. So in Snappy, you need to apply tricks, measure stuff. Be careful with the surface mesh here. Instead, we don't have those problems. Let me go here. Let me put 20 layers. Update. And now also let me go to my religion. Okay, let me do poly export. Okay, so we have also here avoiding that transition and global center. So let's generate this one. So look at that here, unless, as I say, unless you have a very complicated geometry or you make a mistake now here on your screen, it's unlikely that you are going to have a back mesh. But still, from time to time, you can see back quality elements. Always related, by the way, with the aspect ratio, I have to point out. Like in this case, so see here that is telling me that minimum orthogonal back quality, but it's 0.044, which is not much. And usually you can see here. So basically in this region, clearly now, and maybe also skewness will be a little bit high. Okay, but this is not a problem for me. This value, let's say using fluent meshing, as low as 0.005 is okay. So at this point, okay, for instance, let's visualize this mesh. Let me insert there, clipping, now, bum, 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 bum. Okay, display faces, and there you go. Okay, here, there you go. So see that you fill in with poly, and these are beautiful now. The polyhedron are beautiful. This is my religion, and there you go. Much better mesh. And look at that. We generate a super, super, super fine mesh. That to do this in a Snappy, you are going to suffer. You have a few bad quality elements there, but not a problem. So you can here right click insert, you can use this improve mesh. Let me save this one. Sometimes can give you problems. And let's say, let me put here 0.1. So now we will try to improve these specific elements to reach this orthogonal quality. You have different options. This is what is missing in snappyHexMesh. You cannot do this. However, you have CFMesh, and CFMesh, you have that tool that can smooth scenes, and then there are some other externals libraries that can do it. Again, you have here some other options, but let me go here, improve mesh, and let's see what we get here. If it managed to improve this mesh quality here, this mesh issues. But as I said, this is not a problem. You can export it later and read it in OpenFOAM. Then I would prepare a video to show that because you have to be careful that the only thing that you need to export the image in ASCII format, like many things that we have seen, have to be in ASCII format. So when you save it, there is some hidden keyword that to say that it have to be ASCII. So at this point, it is computing the earth improvement. Let's wait a little bit. Okay, so we have a mesh and it tried it. So it wasn't rich, improve is better. Now you have these cells, but as I say, this is not a problem. And we're okay to go. So we have here a valid mesh. Okay, there are the layers, a display face axis, and we're happy with this. So at this point, if you have the tool, you can try different techniques. Polyhedron is the one that I prefer. And this is it. So see how your life is much easier. You can reach very, very fine boundary layers here with no problem, since that with Snap are tricky. By the way, here you can report, and for instance, you can go to set limits, and here you have different quality metrics, and you can go to aspect ratio. And in this case, look at that, the maximum is very high, 2000. Okay, so if you read this, OpenFOAM will complain immediately. So the same aspect ratio, the same issues with aspect ratio, you have it here. Okay, so that is a same issue. Now it's a geometrical measure, so it's not going to change from software to software. You always have it, and there are things that you need to be careful. Okay, so yeah, at this point, if you want to save, go here, mesh, you save it. What I was saying to save it in ASCII. So this is here I'm saving binary, okay? So, but OpenFOAM is not going to convert it. So if you want to save this in ASCII, go mesh, deselect this. Very important here. Select the legacy format, all files, okay? And like this. So you save it in format .nsh, okay? And this is the ASCII format. And in that one, that usually ASCII files are big files, you are going to have, your mesh that then you can convert using Fluent to OpenFOAM and so on. Just to show you here that this, again, this is a human readable file, okay, but you need to understand the Fluent format. But there you have. So you see that you can understand a little bit now coordinates, then you have connectivity and so on. So this is very important. If you want to use this mesh in OpenFOAM, you have to go to save it in ASCII format. So very often people forget that and you get into problems. Okay, so this is just to show you how your life is much, much easier using tools that have a GUI and they don't have that data structure like in snappyHexMesh. Even here you have it, but you can see that you can control everything very easily. You also saw a lot of similarities, okay? And I have to say something that as well, when I was doing some debugging and testing, I did many meshes here and I was measuring aspect ratios and so on and comparing with Snappy, and you get very similar values, and you realize that it's Snappy when it's failing and so on. So that's all. Thank you very much for your attention. See you next time. Bye.